Ankita ma'am, good afternoon. Good afternoon, ma'am, and welcome back to all the participants, and ma'am, welcome back to the third session of day 3. So Dr. Ankita Saxena will be delivering on urban growth modeling methods and application in the third session. Ma'am, can we have those questions back again related to? There were some
please.
two questions.
Yeah, sure.
Like one question was from Dr. Praveen Thamse. Yeah. Apart from ArcGIS, is there any another open source application?
Open source application. If we want QGIS is the replacement of ArcGIS. But if we talk about object-based softwares, then I would say no. You can go with ADAS Imagine. You can perform ADAS object-based methods using few methods are available in ADAS Imagine, but on a trial basis, you can obtain ADAS. But no, there is no such software for object-based really available.
Ma'am, second question is from Dr. Nisha. Is it possible to process Hyperion data using ArcGIS?
Not ArcGIS, but yes, ADAS Imagine. It is possible to process Hyperion data. Yeah.
So to all the participants, again, I welcome Dr. Ankita Saxena from Crucial Institute of Technology. She is working there as scientist and postdoctoral fellow in the Institute of Meteorology and Climate Research, Atmospheric Environmental Research. So welcome to the third session again, ma'am. And you may please
Thank
start
you so much,
your...
Dr. Manoj. Yeah. Okay. So are you able to see my screen?
Yes, ma'am. It's visible, ma'am.
Okay, thanks. So this session is about urban growth modeling and its methods and various applications. So before starting, I would like to introduce about land use and land cover, to which we are saying land use is and what is land cover. So usually land use is the utilization of available land for the utilization for fulfillment the needs of human beings, which is done by man-made. So all the anthropogenic activities associated with the land transformations are considered as land use, and land cover is it's at larger scale and naturally available land over the Earth's surface. So that is how we differentiate between land use and land cover. And land use land cover change is the conversion of land from one feature into another. Like, for example, open land, sometimes used for constructing settlement or built up buildings, infrastructure, creating infrastructure. So that is how it is transformed from open available land. From trees, sometimes by cutting trees, we make land available for other purposes. So how trees are being transformed, tree spaces is being transformed into open, and forest areas are usually used by cutting forest into settlement, and forests are also used for agriculture, and from open to grassland, water to settlement, trees to settlement. So there are these are land use land cover transformation from we say land use land cover change. Over years, if we are analyzing this change, so we need different satellite images, and we analyze changes from land different years to different years. And similarly, if we are more focused for urban activities, urban studies, so there are synonymous terms which are being used for urban growth, urban land use, urban growth, urban sprawl. There is a very thin layer between urban land use, urban growth, and urban sprawl. Urban land use is the utilization of land for the development of any construction, maybe commercial sites or industrial sites. So this is known as urban land use. Urban growth is existing structure, and it is somehow increasing, maybe vertically or expanding horizontally. So it is known as urban growth. And urban sprawl usually takes place at the outskirts of a city in a staggered manner. So it's known as urban sprawl. However, sometimes we can use these terms synonymously. And impervious cover is a well accepted indicator of urbanization. So if impervious cover is increasing, then we can relate it with the increased urbanization. So this is how this graph is showing how in recent past, with the increase of population, urban growth has been increased. Especially in urban areas, metropolitan cities, population has been increased just for the sake of employment, or people are transforming from rural to urban areas, and that's why their needs are being increased. So they seek more construction in terms of infrastructure or houses. So that's why how the urban growth is taking place. And since urbanization is taking place, it requires more land. So it is utilizing the available open land also, but it is on the cause of some resources, like in terms of water bodies or forest, trees, and some other areas are being converted into urban areas. So it is increasing the water pollution. Because construction industries are being increased, more pollution is being deposited. So it is sometimes thrown in water bodies. So it is creating water pollution. It increased for water built-up activities are leading to the water pollution, and it is also contaminating the air. Air. By polluting, by which is created from refineries, mills, and different sort of industrial activities. And as urbanization is increasing, urban growth, population is increases, so traffic congestion kind of problems are also very common just because of urbanization. And loss of farmland to, because people are moving towards the urban areas, and whatever rural land is available and not being used for farms anymore, and those are places being converted. And by cutting the forest, deforestation like situation occurs, and it is again the consequences of increased urbanization. And urban heat island is associated with the climate change impact, because as the anthropogenic activities increases and pollution increases, it goes in the atmosphere, and somehow local climatic influences are being deposited, and it creates urban heat island. So the studies suggest that if there is more urbanization, there will be more urban heat island effect. The surfaces which were relatively cooler in recent past, but now have become more hotter as compared to previous time, just because of increased urbanization. So this urban heat island phenomena is just corresponding to the increased urbanization. And urbanization is also causing habitat loss, biodiversity loss, aquaculture loss. So these kind of losses and environmental ecological impacts are very significant, and researchers are doing researches in these areas. What are the implications of increased urbanization? So urbanization and urban growth assessment is a very important concept to be studied, all these impacts. Urbanization and urbanization processes are how it takes place. So usually it starts with the random staggered urbanization. For example, if real life example, if I would like to give, urbanization starts from outward dispersiveness, external random urbanization, and then it starts looking around for more urbanization, because people get attracted to those places where there is urbanization, already urban places. because it's a human tendency and it's a natural concept. Like if there is some sort of build up, then there will be needs infrastructure is being constructed. Again, urbanization, part of urbanization, and hospital facilities, school facilities, different types of facilities to fulfill the human needs. So this is how urbanization expand with time. So this is the way of expanding urbanization, but how these kind of urbanization, and where it's a very complex thing, although because it is involving so many human decisions, how human think, how human decides to construct his houses, and what are the explanatory variables which drive urbanization to grow further, maybe horizontally or vertically. So all these complex things are a part of this urban system, and we need to understand this complex relationship between urbanization and different urban drivers which are driving urban growth. So to understand all these urbanization phenomena, we need to have the knowledge of models. And models are on the basis of models, of course, using some data. What kind of data? It should not be always statistical data, because we need spatial information also. So spatial information we can get from GIS, remote sensing type of technologies, which are providing us the satellite information about the geographical land surface on a larger extent. So we have large extent information in terms of satellite images, and we perform those satellite images to get the meaningful information. And by using those satellite images, processing those satellite images, we need softwares, and we need to have a know-how about the technologies, how to process those data to get the urban information of different types. So that's how geospatial technologies are playing their role in capturing satellite data and processing, pre-processing and processing data, so that we can use those satellite data in a meaningful form, and can create data set which will be a part of, will be treated as input data set to a model, which will further model the urbanization. So it's a chain. Like from satellite data, we are getting satellite information on the one hand, and using software, tools, techniques, method, we are processing those satellite data to get the urban information. But only getting urban information is not required. I mean, it will not serve the purpose in better planning and positioning of the things. Means in how the urbanization and land use are being changed, will be changed if the present situation persists. So to forecast the future, we need model. So only detecting by chain detection method, land use and cover chain detection method, it's not serving us the purpose. So to analyze the future, how the future will be like, so we need models. So GIS and remote sensing are playing crucial role in that respect. So as I was saying, system which is governing the urbanization system, how urbanization is being placed. So lots of variables are involved who are driving for urbanization. Like there are economic variables. If we talk about economy, so definitely urbanization depends on economy. Like what's the land tenure, farm sizing, distance between from urban locations to market access, what is the accessibility from your urbanization to market, industrial activities, how far is the industrial place is from your residential, if we are talking about residential. So how far is it? Means industrial, sometimes it is understood that industrial activity should not be mixed with the residential. So these comes under economic variables. So these are economic drivers, and demographic variables also play a role, like population density. So more the population, more the population density, more the urbanization. So because urbanization demand increases with the increase in population demand, So if we have population idea about the population density, then it would be good to model the urban growth. And also it of annual income of a person, per capita income, how how much is the capability of a person of buying or building new infrastructure or houses, and what kind of houses. Means if we talk about for uh, affluent classes, we have higher infrastructure, higher housing buildings, and for poor people, we have lower dense, very dense urbanization. So means uh, income area, we have higher population, for less higher built up. So these kind of relationship also we need to understand while we are modeling urban growth. And also neighborhood variables like proximity things, proximity from main railway station, roads, other transportation networks, or basic infrastructure things like hospitals, schools, and some recreational facilities. It's an aesthetic part of urbanization. Like people do prefer to build their houses near parks. They see, they look around for recreational facilities. So they think about those things before building or buying their houses also. Or and yes, of course, land cost is also a part of economic, because land cost also play an important role. What's the land cost of that locality? How the people are, means, people are, their education level, if they are literate or not, what kind of society is they living, what are sometimes religious things also play an important role in deciding or building houses. And these come under social drivers, that literacy and human psychology about religions. And some site specific other variables could be a part of this modeling. So this is how these complex variables are driving the urbanization. Urbanization may be in terms of residential, industrial, commercial, institutional. And this relationship, to handle such complex relationship, we have different modeling approaches, which could be on the basis of machine learning. We might have heard this name from last few years. We have started learning about this machine learning things. It's a new concept, not new, but yes, it is evolving with time. And it is also considering some statistics. It's a computer-based thing when you need to handle different combinations. So machine learning helps in that sense to handle different relationship, because there is no single one variable which is influencing your urbanization, but there are so many variables which are influencing urbanization. That's why there are so many relationship combinations we need to assess with the data. So machine learning based modeling approaches are good, and it is a pattern based because it is generating patterns of urbanization, and it is strong in stationarity and can give you the idea about the urbanization in future. And it requires land use, land cover information, and some predictor variables like what drivers are you considering for analyzing your urban growth. Cellular automata based approach, it's a cell-based approach. It is very popular in urban growth modeling and land use, land cover change, because cellular, as the name suggests, the rules, the information is applied on a cellular basis. Cell basis means pixel basis. So it is very helpful and can be easily handled in GIS also. That's why it is good in handling complex relationship of urbanization and different drivers, and especially disaggregated economic models. So as the name suggests, economic models. So to handle economic qualitative in nature, it's very hard to get economic data on a spatial basis. So there are some specialized softwares, so models which are handling this economic activities, because economic itself is a big concept. So separately we handle economic things, and then we relate it with the urban growth models to arrive at the final projections of urbanization by introducing different relationships among different variables of urbanization. And agent-based models are good enough, and sometimes used alone or sometimes in integration with cellular automata-based models and other models. Agent-based models are usually preferred over other models in the sense to introduce human behavior. Human behavior is a thing which cannot be, it's a qualitative concept, not quantified. It cannot be quantified. You can, by using some crude methods, I would say, but it's not very straightforward to scale the human behavior spatially, especially. And that's why agent-based models are works in the form of agents. Agents is a person or is a agent who is making choices, making decisions of converting one land use class into another on the basis of different opinions, different choices of human mind. So that's how it is handling the human behavior in agent-based models. And these are the other things which we need to take into consideration before deciding what model we are targeting to use and what modeling approach we are targeting to use, because it depends also on what kind of analysis do we want. Means if we have, or what kind of data do we have, like if we have information about where and when in the past the urbanization has taken place, and we want to analyze when in the future for short term. Here the term short term. So for short term, stochastic and transition probability models are good, which are giving you some probabilistic idea, because for short term probabilistic ideas are okay, and it's easy to handle for short term in a probabilistic form. And why in the past means you have the reason why in terms of your causative factors, explanatory variables. If you have those variables data also, then you can always go with multivariate statistical modeling, these methods, because there are multiple variables and you have urban growth as a dependent variable and you have lots of independent variables. So you can try to fit the relationship using multivariate statistical method. And if you have where, when, and why in the past the urbanization has occurred, then and you want to analyze why in the future, means the causes, why, what could be in the future, then you should go with analytical agent-based and economic-based methods, because it's a complex, lots of variables are involved in making decision of urbanization. So you need some sophisticated modeling approaches to analyze urbanization and their relationship between among variables. Sometimes it's a deterministic and sometimes it's stochastic, but it's so stochastic methods are always preferred over deterministic ones, because probabilistic ideas are always good to know that in probability, because nothing is determined, things may not be that appropriate to give the exact information. So probabilistic methods are fine for urban growth type of phenomena. And we have different models using those using those modeling approaches, like I have discussed cellular automata, agent-based, and other other approaches. So we have Dynamica, Lucas, SimLand, UrbanSim, PLM, GEM, Prism, ID3, Sleuth, Karba. These methods belongs to different approaches of modeling, like agent-based, cellular automata. And yes, these are all popular ones in their area. Sleuth is one of the most famous models in the area of urban growth modeling. I will be discussing it in detail more later in later slides. So first model, if we talk about CLUE. CLUE is a land use model, which is not only targeting urban growth, but other land use classes also. And it is especially explicit model considering different socioeconomic factors. The advantage of this method is that it is considering the demand, demand of population, demand of urbanization, on the basis of different variables. So demand is being produced separately, and that is being used as an additional factor to produce the urbanization. So it is considering logistic regressions to derive the urban growth in future. However, some limitations are associated with, because it's not very straightforward to set the relationship between different explanatory variables and urban growth. And it's not also not giving you the final, long-term projections for the urban growth, because it's very complex with CLUE in that case, because including lots of demands and variables. Curva is another detailed, spatially explicit model. It is considering demographic, topographic, socioeconomic factors, and some proximity variables also. It is also establishing the relationship between urbanization and explanatory variables using logic models and by using some statistical packages also. And it is also not giving us long-term projections and also not giving us the maps, spatial maps. That's the limitation with this model. There's another one, Lucas model, which is ecological, social, and graphic factors are being considered in this model. And also it is using multinomial logic model to derive the transition probabilities from one land use class to another. And few limitations are, one of them are like it's not giving us the proper long-term projections and maps, geospatial maps. So all the differences are on the basis of of the data set, what input data set they are using for producing the final process and final outcomes, and what drivers they are considering. So this is the variation. Main drivers. Second thing is the method they are using to drive. Sometimes these multinomial regression relationships are not sufficient to give the exact information. That's why they are lacking in some aspects. And Dynamica is another model which is considering some socioeconomic factors and infrastructure factors, and can be handled in the GIS also. And UrbanSim is specialized for urban growth model. And SimLand is another model which is considering socioeconomic factors and topographic factors. And different variables are included in the sense of by computing multi-criteria analysis, their weights, and then against those weights in the sense what variables are you preparing over more. However, the limitation is that the explanatory variables which are driving urban growth may vary with the locations, with the means for developing countries, it would be different, entirely different than developed countries. And itself in India, if we talk about in India, it's a very diversified in terms of socioeconomic conditions and topographic conditions. So same sort of variables may not be appropriate or may not be uniformly applied all over the India. So that's the thing we always need to consider while building our urban growth models. And some other models are DUM, which is also giving us direction and density and about the urban growths in terms of probabilities. And FASOM is a model which is considering economic factors also, and it is using some optimization techniques to derive the best combination of weights for different explanatory variables of urban growth. based on that, urban growth is projected. And GEM is considering biological and physical and abiotic factors. It's a ecological model, especially designed for ecological aspects, but can be applied for urban growth also, because it's a rule-based transition algorithm. Same sort of rules we can frame in urban growth if one want to use GAEM concept. PLM model is especially explicit ecological economic factors. It is including and used for mainly pasture land model. It is and for used for green lands, but can be applied for urbanization also. And PRISM is another model which is considering so many demographic, economic, and environmental and policy. Policy is another major aspect which is being considered for designing sophisticated urban growth models, because policy is a term which reflects our future scenarios and future implications. Because sometimes present condition may not include, may not be very much legal in the sense of urbanization, because in India, in Ajmer, when I was studying in Ajmer, I was doing my PhD there, and then I saw that in Ajmer, urbanization, lots of urbanization is there on topographical slope, to higher topography, steeper slopes. However, it is not permissible. But whenever plan will be and policies will be framed, so these kind of things, these kind of implications we should take care in modeling if we are targeting sustainable urban growth scenarios, and which is now a future demand, and it is an important part that policy should be a part of urban modeling. And CUF is a multinomial logic model, and it is also considering different site-specific characteristics like disasters. Urbanization should not be in the disaster-prone areas. That could be in the form of earthquake disasters, sometimes floods. In India, sometimes earthquake, and yeah, drought and flood. Drought, I don't know how much it will affect, but yes, yeah, earthquake and flood are the major things, or maybe landslides also are major site-specific characteristics which should be involved in urban growth model. So this is an overview of the various famous available models in there, which are corresponding to different modeling approaches like cellular automata and agent-based machine learning, artificial neural network, multinomial logistic regression. So all these models, the difference is that what outcome do we want? Means long-term projections do we need, or we are more interested in short-term urban growth projections? And what data do we have? Means it also depends on the availability of data. Sometimes we want future projection, long-term projection, and we want to consider these and so factors, but we don't have data, so we cannot use models. So our selection of model should be on the basis of the availability of data, and of course what we want to project in future. Means how long are we aspiring to project our urbanization? And in our study, or what implications are you targeting? Because, okay, if you have an idea about urbanization and how you are relating it with its cascading effects, like you are analyzing implications of urbanization on climate change or environment, or in which area are you applying your studies? It also depends when you are deciding your models. So I have briefly discussed different approaches. One of them is cellular automata, which is very famous one in terms of, because it's very straightforward, not straightforward, but complex thing can be easily incorporated into the cellular automata. Cellular automata, as the name suggests, it's a cellular structure. It's a infinite lattice of cell. Cell means raster, cells, grids, and each cell has its own state. State in the sense active or inactive, because it is dependent on the life birth phenomena. And each cell has its state in the sense of either it is dead or either it is alive. A third state we can introduce in the sense like it will survive. Survive means remain with the same state which already it has. So it's a chessboard kind of structures because any geographical surface, any phenomena which can be represented geographically can be used in cellular automata. Can be represented easily in cellular automata with the help of its states, its transition rules, and it has some neighborhood, because it is believed that various geographical phenomena are natural phenomena, and because it are spreading or expanding on the basis of its neighborhood concept, neighborhood characteristic, because it looks around its neighbors for happening. Like if we talk about urban growth, because it will see around, if it is urbanization is there, then it will urbanize further. It will expand in urbanization. And similarly, you can relate it with the forest fire. Forest fire will spread because it's a geographical phenomena, or it's also considering it's natural phenomena that it will spread in its neighbor. The phenomena which are spreading or which has capability to extend or spread by considering neighborhood effect, there we can apply this cellular automata easily. So urban growth itself is a complex phenomena, but can be handled easily in cellular automata. So as I said, it's an infinite lattice of discrete. So it's first given by von Neumann and later refined by Wolfram. And it has some internal clock also, which is being updated with the time. Time in the sense years. So we have different time series data for urban. Now we will talk about urban. So we have time series of urban, different years, and how urbanization has been taking place with time. So the probabilistic term is involved. How much probability is how much is the probability from one time year to another time for urban growth. So probabilistic is one term, and there are another term is transition rules. Rules are in the form of their explanatory variables, which I was discussing, like economic variables, proximity variables, and so on, which variables are affecting your urbanization. So those variables can be included in the form of transition rules. It is one thing. And another thing is probabilistic term, which is a time series. So these combination makes complete cellular automata. So how this is the cellular automata. And the like it is including, which is considering the neighborhood effect, which I was saying, life, death, and survival, and how it is implementing with the help of these rules. For each and individual cells, it is looking around the neighborhood could be of 3x3 cells, 3x3. It will look around in the 3x3 system, or maybe 4x4 or 5x5. It depends which neighborhood is more appropriate in giving that idea about the phenomena you are targeting. In our case, we are targeting urbanization. So initially we can say, okay, we are considering 3x3 neighborhood. So in 3x3 neighborhood, how the decision of this pixel is being taken for converting it into urban. For example, there is one non-urban cell, and then it will look around the urbanization, how many number of urban places or urban locations and are available. If it is less than 3, then it will not get urbanized. Means it could vary from 3 to 2. It depends on developing and developed concepts, because in India it's very dense. So we will not say 3 urban constructions should be around. We can say, okay, let's 1 construction will be enough to instigate the urbanization. So we can modify this term. So I'm just taking an example like 3. If there are 3 urban pixels are surrounded by that urban location, then it will be urbanized. If it is not, it will not urbanize. If it is the pixel for which we are testing, it is already urban, and but it is surrounded by few pixels, then it will not survive and it will die just because of isolation. Because if you want to segregate the urban terms in terms of industrialization and housing and residential and commercial and infrastructure things, so a residential place cannot survive if there are so many, it is surrounded by so many commercialized infrastructure. It will, with time, it will be converted into commercial activities. It's a real example. So that's how real concepts we can introduce in the form of rules using cellular automata, and we can project our urban growth for future. So Silute is the model which is very famous one given by Professor Keith C. Clark from University of California, Santa Barbara, and this is based on the basis of CA concept, Cellular Automata. So as the name suggests, it's an acronym for its input data set. What input data set do we need? Like we need slope, topographical information is required, because it's required in the sense we will not want to build any kind of construction on steeper slopes. So that's why it is required. Land use information, historical land use is required only when if we are considering complete land use. But if we are considering urban growth, then it's not required. Then exclusions could be in the sense of water bodies who build their construction or houses. So that's why it's not required. So we need those places to be excluded. So we need to, because it's a model, it's a software, we will have to specify things where we will not want to build our constructions in the form of water body, historical places, and some recreational places, parks, could be anything which we want to exclude from urbanization. And next is urbanization. So we need historical urbanization information, how urbanization is being taken place in the past. And we need transportation networks, proximity from your places, your urban to the main roads, or maybe railway stations also, but we have considered road only. And hillshade is just for visualizing purpose. There is no role in the calculations. So yes, CA is Silute is a CA based method. And why is it good? Its advantages are it's scale independent, it can be applied to any scale, and it's dynamic and future oriented. It can be applied in the different conditions. It can be applied in different socioeconomic conditions also, and for same sort of conditions also. So yeah, this is the advantage of Silute. And it is an open source model which is available. It is written in C programming language. It has its website, and you can create your data set and you can calibrate the model. So calibration is the crux of that model, which needs lots of information about that model and how urbanization works. So this is the complex part, calibration, how to calibrate the model. Otherwise, it is freely available. If one is interested, can test this model anytime. And this is the complete methodology of this model, this cellular automata-based model, how it works. So as I was saying that it requires slow and urbanization, transportation. This orange part is showing us the input information a model requires. So this is in terms of input data set, which is prepared in some specific formats which model accept, like it requires raster-based formats. So yeah, so you need set those formats. And there are some scenarios where you need to specify the start and end date of simulation, from which date you are starting your simulation, your model simulation, and the end date, until what date you want to calibrate and further predict. And of course, it is dependent on so many parameters, which also control the urbanization calibration process. So those also need to specify here. So this is input. This input goes into the sleuth model conceptualization and parameterization. We do the parameterization part after providing the input data set to the model, and we then test the model to test if it is accurate, to means it's ready to run. The input parameters are set accordingly, and what the input data sets formats are, if it is in its accurate form. If not, then model will not run. So testing phase is helpful in that sense. After testing, this blue is the complete calibration process, which is crux, and we refine the coefficient values of this model in a sequential and multi-phase way to obtain the best representing coefficient values against which we will want to predict our future. So coefficient values and calibration is nothing but just fitting the historical maps with the modeled produced outcomes by using some statistical measures. Like there are so many, more than 13 metrics, which computes the least square regression between urbanization and modeled urbanization and historic urbanization in terms of urban edges, urban clusters, areas, and so on. So if we are satisfied with the calibration and best fit values of coefficients, then we will use those values, those coefficients, best fit coefficient, to produce the urban growth for future. So the coefficients I am talking about are these 5 coefficients, which are controlling the 4 types of growths. So 4 types of growth means there could be different type of growths, like spread growth, dispersive growth, road influence growth. So for controlling those growths, we have these controlling parameters in the form of numbers, which gives us some kind of probabilities, and which are being calibrated in different cycles, different Monte Carlo simulations. So the idea is to obtain the optimum values for these 5 coefficients by performing calibration in multiple phases. And when we get this optimum values, then our calibration is done. And how we can say that, okay, these are the best values? So we can check by analyzing spatial and statistical measures that will reflect if calibration is appropriate or not. So spontaneous growth rule is controlled by diffusive urban growth parameter, and what it represents the overall output dispersiveness, random dispersiveness. New spreading center is controlled by a breed growth controlling parameter. It is a newly urbanized, urbanized location, which will start further spreading in future. Edge growth is about spread. It's a cluster type of growth it is reflecting, and road influenced are corresponding to the road, along the road networks. What is the probability of being urbanized? And there are some suitability conditions checks also in terms of slopes. and some restrictions in the form of extrusion layers. Self-modifying is the secondary level of growth rules, like for unusual growth rate, high and low can be controlled with the help of this self-modifying parameter, which is basically giving us a non-linear urbanization, which is a very important characteristics of any modeling. We always want our S-curve growth, S-curve changes, not linear, but we want non-linear. So that's why these secondary growth rules. So this is the same growth rules on the right-hand side: spontaneous growth, diffusive growth, organic growth. These four growth rules are controlled with the help of these, on the left side, these 5 coefficients. And all coefficients have 0 to 100 ranges. And these 0 to 100 ranges are being refined in number of Monte Carlo simulations. So for each Monte Carlo MC runs, a possible combination of these coefficients are being tested to produce corresponding outcome. And this is how urbanization works. In the beginning, this gray pixel is showing the spontaneous and growth. And then in the neighborhood, the growth is taking place. And then again, it's spreading in the form of organic growth. And then road influence growth along the road network growth. So this urbanization concept is being formulated with the help of cellular automata. So here we can see this is cellular structure, and each and individual cell has its states, and which are controlled by some probabilistic future, historic relationship, probabilistic relationship, and also the transition rules, which are governed through these 4 rules. And these are secondary level growth rules, which are controlling the non-linearity of the system. And this salute model was implemented just for the application. It was developed first, then implemented, applied for the Ajmer city of Rajasthan. And this is the data which was used to calibrate the model: multi-date satellite data of different years, Sheet, master plan, AutoCAD maps, softwares. We used ADAS, ArcGIS, and Sigwin, because Salute model is a Linux-based model, and I was running it on Windows, so Sigwin was an emulator. I used it as an emulator. So this is the satellite data and their information. And this is how urban maps were produced. This is the satellite data, classified outputs, their corresponding accuracies. And this is the form in which model accept the inputs. Like it is raster GIF file formats, it accept in that form. And these are historic urban maps, road networks, slope, and hill shade, just for visualization purposes. So as I was saying, that calibration is the crux of this model. So things are being refined over the phases. So first it starts with coarser range, like 0 to 100. It runs for the complete range, each and every combination for those coefficients tested, and produces statistical measures or least square regression fits. And then we refine the values of those coefficients. Then those refined coefficient values are further used for fine calibration. Then we get some optimum values from that calibration phase. And then those refined values are further used for final calibration. So this is how calibration takes place. And for each and every combination of, we have this metrics like best lease LE metrics, best OSM, and how much computational time it took in number of seconds. So this is the summarized way of representing the calibration process. Lease LE is the shape index of urban, because it's not area, it's not something else, it's not a number, but it's giving you the idea about the shape. So it is nearer to the one, it is accurate, but it's very difficult to get such a good number. So even more than 0.3 is considered better for urbanization. And best OSM is a combination group of different metrics. So these are the criteria of evaluating the growth coefficients. So these are the growth coefficients in different calibration phases, their values, so which reflect that which kind of growth will be prevailing in different locations. Like for example, in Ajmer, road influence growth will be higher and slope will be higher. And then comes spread. So it also gives us an idea about what kind of growth will be prevailing in areas, in different areas. So it's not necessarily be the same for different regions. It could be anything. It could vary with different regions. So it's always interesting to test it with different scenario, different regions to get a broader picture about different kind of growth. So this is how land use change has been projected for different futures. Like up to year 2019, we simulated using the Cellular model. It's showing the land use land cover change projections by considering those parameters, and how the land use classes features are being changed in terms of areas. It is showing that urban is increasing, and like settlement you can see is increasing. Riverbed is slightly decreasing. Riverbed is nothing but the water body. It's a part of water body because there is no such water body, but yeah, it's about part of water body. And some vegetation, how it is declining with the time. And this is the urban growth. How urban growth, red is showing urban growth. So from 1998 to 2018, how it's been expanded. And it's also showing you the directions, special information also, where and in what amount the urban growth will take place. So we used, as you might have noticed that we used the data until the year 2015, and then we validated the outcomes, model produced outcome of year 2018 with the fine resolution data, satellite data, to validate if the model is able to predict the growth in an accurate manner. So these were the methods which were considered to evaluate the outcomes of urban growth. As you can see, the accuracy percentage has been increased in different models. So the idea was CU default was with default conditions as it is what means without any modification, the naturally available model. And I developed two different variants of this salute model, like salute sensitivity, in which I tested its various parameters for its sensitivity, because the idea was the same sort of parameters which are constant in the model may not be appropriate for every region. So because it was developed in California and was tested in those conditions, so it might be different in our conditions. So it should not be constant. So by using those sensitivity testing, I improved that model and the accuracy was further improved. And the suitability concept was to introduce suitability variable. As we have noticed that SLUTH, as the name suggests, it is including only slope, land use, urban, exclusion, transportation, and hill shade. But it is not considering other explanatory variables like land cost, proximity variables like proximity to recreation places, hospitals, schools, market access. These kind of variables were not a part of the original salute. So I added that suitability concept into the salute model. So it increased the accuracy. If we simply compare it with the georeferenced GUI Google Earth data. And if we considered it, if we validate it with the field validation by taking samples using with the help of GPS, so I figured out that it is well locating the locations for the urban places, even for those newly developed locations which was not a part of the input data set, but it is able to predict for the future. So it was well validated, and we found 83% accuracy for that. So that was quite interesting to see that how that suitability part has improved the accuracy of that model. And these are the statistical metrics which I was talking about, that how it has improved in this suitability version of the simulation. And also this is the correlation relationships. It is also good in suitability. And this is a visual clips from the Google Earth. So blue thing is from blue urbanization is from the suitability, which is after introducing the land suitability concept into the solute model. So the default model is with red color. So we can see that it is an urban cluster, and which is model is simulating just a few pixels of urbanization, which later improved with sensitivity model, and which significantly improved with the land suitability, this blue. So it is completely able to capture the cluster. And how the growth rate has been, urban growth is taking place. It is going to be increased in future also, but the rate will be slightly narrowing down in future. That's what study says from this. And it is highly relevant also if you talk about statistics that are also showing that the growth rate might be declined with time. And this is the aerial statistics, how area is going to increase in near future, urban area. And this is an additional capability into the urban models. Like until now, we were talking about horizontal expansion, how urbanization will expand horizontally. But we were not considering the density, built-up density concept or vertical concept into the modeling. So this was the additional capability which I introduced into that solute model by considering the number of choices a person is taking for the same place. Means how many persons are willing to take that location for their urbanization. That could be derived from different explanatory variables, land suitability variables. So that concept was making choice was introduced into this built-up density, and which was well related with the built-up density. Urban intensity means how much the urbanization has been changed for the same locations. So which indicate intensity. So how intensify the urbanization is with the time. So that was well related with the urban built-up density, which I simulated with this model, and also was well related with the population density concept. So it's a usual fact where population density is higher and urban built-up density will be higher, should be higher on those locations. So we have got the good relationship between population density and built-up land density. And third, the number of floors. So I visited the field and I noted down the floors for more than 80 locations and tried to validate with our simulated built-up land density outcomes. And well, it matched. And some other phenomena also, like I was referring LST in my first lecture, land surface temperature, as I was discussing, that where the urbanization is higher, the local climate, I mean land surface temperature of those locations will be higher. Where the higher the built up, higher the land surface temperature. So it was also well verified that those indirect land built up density aspects also. And this is visual interpretation, and the location we know the our model is was able to give the density, higher density against the multi story buildings was able to capture. So this was very verified with visual analysis by during our field visit. And sorry, I'm not able to see. Yeah, so urbanization, yeah, urban growth is going to take place, but with not increasing. It is going to decline, but yes, urban growth will take place. So this was about the urbanization, urban growth models, and how urban growth will make difference in building policies and different scenarios. Because now you have an idea, you are capable of suppose you are capable of producing urban projections, but how you are going to use this urban projections in sustainable land use planning. So this is further it's extended discussion. Like urbanization is as population grows, and it is influencing, or maybe it is affecting the population also indirectly. If population is increasing and urbanization is increasing, but it is again affecting that whole population in some sense, in terms of climatic consequences, environmental consequences. So we need to develop some sustainable scenarios, and how we can address, we can include those sustainable scenarios into the modeling, and then we can see, okay, if we go with this sustainable, with this scenario, then how the growth will look like, what could be the direction of urbanization, and what will be the growth rate, and how people will move from one location to other. So in using modeling, urban growth modeling, we can explore different alternatives. Then we can finalize, okay, this one is the best. So this is how modeling helps in building sustainable urban scenario. So sustainable development definition is says like development that meets the need of the present without compromising the ability of the future generation. So it's a very perfect definition, which is quite difficult to obtain. But yes, planners and policies makers are trying hard to achieve those goals. So how they can incorporate those sustainability terms into our day-to-day life. So our day-to-day life is not only about building houses or something like that, but how our day-to-day decision is making great changes in the climate and sustainability terms. We talk about broader concept, like how we are making choices in eating habits, food directory habits, or maybe traveling habits. And these are some social aspects. So it's very hard to define and to introduce into the modeling, but yes, there are some ways to include these choices into the modeling. So likewise, some economic parameters which also affect our, as I was saying, socioeconomic parameters like social. If we talk about social, then some cultural, things. What society, what education, what kind of religion are around, so that we will win our houses. So these kind of choices are also a part of this modeling. So also a part of those sustainable scenarios. So we should frame our scenarios according to locations, according to those variables, and then try to model against model for those scenarios. That's how sustainability can be achieved through modeling. And so it gives us a change in quality of growth. Different environmental and economic factors can be associated with this modeling. And yes, natural resources can be, means their depletion can be controlled with the help of modeling if we are trying to introduce different sustainable scenarios in modeling. And yes, there is a strong consideration about future generations. So this is how to develop. Dr. Manoj, how much time do I have?
We can.
We can. Okay, thanks. And yeah, so these are the broader picture of implications of great urbanization. So these implications could be incorporated in urban growth modeling by considering different scenarios. Okay, we don't want deforestation. We want to protect our forest. So we should reserve those forests and should not be a part of further urbanization. So that's how we can control that. For example, Sleuth was considering exclusions. So I was just saying that exclusion can exclude different locations which should not be a part of urbanization. So deforestation could be one of them. And yes, habitat loss and different climatic factors can also be a part of that modeling. And sustainable urban development, like so according to the European Commission, urban sustainability is defined as the challenge to solve both the problems experienced within cities and the problems caused by cities. So together, though both the things handling is difficult, but yes, through modeling, we can take this as a challenge and we can include, as I was saying, that how human decisions, human choices will affect. Then in that case, we can introduce agent-based, agent choices, human choices we can introduce. And by building different scenarios, okay, we will restrict houses after reaching, we will restrict urbanization in those locations, and we will try to motivate some other um, alternatives. For example, a single land can be used as a functional, like there could be urbanization also, but can also be used for producing solar energy, solar photovoltaic potential in the form of solars. So a single land can be used for the solutions also. So these and same with the wind power, wind energy. If we talk about agriculture, and so fodder land can be used for producing fodder, grass, and also for solar panels. So same land can be used for producing multiple services. So how much do we need actually to produce the fodder, and how much do we need to produce energy, and what land is required for producing two services? So it's basically land, multiple lands. So this could be a one form of sustainable scenario that can be taken up into the modeling, and then we can say, okay, how, if we take up this solution, then how much benefit it will give us in future in terms of urban growth and their adverse impacts. And it helps in proper use of resources, guarantee a generational equity. It protects our environmental and also minimize the use of non-renewable resources which cannot be generated further, and also stabilize the economy. If we plan urbanization, then also helps in reducing the inequality. So this whole is to produce different sort of scenarios which can help to build sustainable scenarios. And protection of natural land, natural environment means there should be not be the chunks of urbans clusters, but it should be surrounded by some natural environment in terms of parks. So there should be some parks also for better and healthy life environment. So, and for the sake of environment also. So this also can be planned through scenarios, and minimal use of non-renewable resources, maybe by replacing conventional energy resources with the help of these non-renewable, with the help of renewable energies like solar panels, wind power. And generational equity can also be taken up in scenarios, in the form of scenarios by by planning, by considering economic factors like GDP, Gini, and PPP, purchasing power parity. So this could also be a part of scenarios which affect our urbanization and plays an important role in urbanization and meeting the need of our uh, goals of sustainability in terms of different socioeconomic pathways and RCPs. And it helps like policy making, I was just saying. And if you have an idea about the urbanization in different scenarios, how it's going to affect, then can take advantage of these modeling efforts. And also it is helpful in budget allocation. If you have an idea that how your urbanization is going to take place and how much will be the urbanization, then you will have an idea to allocate budget accordingly, and budget for meeting the needs of different infrastructures, because with the increase of urbanization, we need infrastructure to support the system. So that's why budgets in different categories. And yes, management of resources can also be taken up if we have an idea about urban growth, future projections. And also natural resources well planned and optimized, because maybe its carrying capacity may not be sufficient to cope up such a large population or urbanization. So it is well, if we are well informed with future projections, then yes, it can be planned. And how optimally we can use land can also be benefit can take from modeling. And of course, if we are doing all the such things, and then it will somehow lead to sustainable planning. And it says that it should be a mixed development which should include our green system, which should well supported by the green surroundings, which will help our well-beingness be also, but the environment also. And protected museums, we would like to protect our monuments, and we would like to protect our natures in form of water bodies or forest or cultural heritages places, because it's required. It's a part of social. We would want to preserve those places, so definitely we should include in those things in our futuristic scenarios to protect, and also to protect environment. So this is the satellite image where we can see that how. Sorry.
All the participants are requested to kindly mute themselves. Hello.
नाही मग बसनच मला जायला पाहिजे म्हणून म्हटलं अगोदर विचारूया म्हटलं.
Hello.
Hello.
Ankita ma'am, there is some
चालतंय बघतो
call from somebody and the participant is unmute.
Okay. Okay. So I'm continuing. So this is the road network. This is the pathways which should be created along the road so that people can walk on roads. So that will promote the individual health and will protect from any kind of accidents, or so it will lead to better human well-being. So these are the things that should be a part of urban modeling, and we should promote cycling, and we should create those pathways on which one can bike, and also it is friendly for the environment. So in that way we are giving better human well-beingness also, but also supporting the environment by producing such pathways, such facilities that can ultimately lead to sustainable urban development. This is how urbanization increases with population growth. And we have a great role of geospatial techniques in sustainable urban development. So land use land cover planning is very important for the sustainable development scenarios. So in that way, we can check how the land use land cover will change and urban growth will take place in future. If we are considering those aspects, which I was just discussing, like creating pathways for cycling and for by preserving our natural areas, water bodies, forests. So it is helpful to protect the nature and also for sustainability. And this is one study which was carried out by testing different scenarios and was considering different ecological, economic, and social factors, and was quite helpful in giving the projections for the year 2030. So that was showing that if current situation persists, how urban will look like, how the resources will get depleted with time. But if we try to manage, we take some efforts by managing growth and by controlling urbanization, and also looking at the ecological and environmental perspective, then how big difference it can create in the environment and human life. And this is another study which was on the basis of different scenarios of by preserving natural places and by creating different pathways for human supporting system like biking and walking. And yes, this is again an example of another study from Cellular in which they considered different variables they included different variables in Cellular modeling by giving weights to, because all factors may not be at equal importance, but we would like to prioritize our preferences to which variable we would like to give more weightage. So that thing can be incorporated with any weighted technique, maybe multi-criteria and evaluation methods or top-SIP based methods. It could be anything to produce just suitable locations based on those variables. You can model the urban growth for scenarios. So these are the variables they considered, like slope, aspect, pedology, geology, proximity variables, forest, and distance to villages, industrial areas, and yes, some classification climate aspects they also considered, like because some areas are very rainy and some are snowy, and these are the factors what one would like to consider in their modeling. And of course it influences urbanization. So on those locations, people may not be more interested in constructing the infrastructure or urbanization. So that's why these drivers play an important role. So we can always include as many number of variables, but it depends on what we want to drive from our predictions. So this was the suitability layer based on those variables, and that were a part of urban growth simulations. So this is another study for Pushkar. Different scenarios were tested. These were, I would say, just fuzzy scenario, and just to see how urban will look like in different scenarios. It was not just so shared socioeconomic pathways, but yes, we proposed that, okay, this is very dense urban areas, but not surrounded by any greenery. So it will affect climate and the environment and the human beings. So we tried to create some pockets, green pockets in between different urban parts where there were no urban places, or there were no green spaces, which will enhance human life, human well-being. So for this, we considered this Pushkar area, smaller town in in Rajasthan, and different time series data from 1997 to 2015. And these are the input maps, like we classified those maps and produced the input data set from those classified outputs, and by digitizing road networks. And these were the hypothetical scenarios. Like, we tried to include different scenarios in the form of exclusions, as I was discussing that exclusion is the thing that can include different scenarios, different factors like water bodies, green, and other things. And these hypothetical scenarios, exclusion 1, 2, 3, 4, 5, 6, which are considering different things like preserving a forest area, water body, and road networks. So how we tried to calibrate that model and tried to project the urbanization. Like, we tried to protect urbanization on rocky terrains. So it shifted to some other locations, which could be a part of urbanization. But if we preserved those locations, then the urbanization moved to different directions. So because then it further leads to betterment of human beings, and yes, it of course it enhances the environmental quality also. Likewise, in scenario 2 also, we try to preserve water bodies. So if you will see that if there is no such kind of scenario or restriction, then this lake is around the lake, urbanization is shrinking this lake. But if you impose some restrictions around those areas, then you can see that urbanization will shift into different direction. And another scenario, we try to create some green buffers, and then we can see that urbanization, which was the part of rocky terrain along the rocky terrain and other areas, which shifted in another direction. So this is how we can test different scenarios, urban growth in different scenarios, and we can prospect different policies, so how it's going to affect our future. So this was the study from. Thank you for your patience listening. If you have any question, I would like to give your answers.
Thank you very much, Dr. Ankita. All the participants, those who are having any questions or like doubt related to the research that Dr. Ankita is involved in, he or she may ask question by unmuting himself or herself. The
So,
type of explanations that you provided. Yeah. Yes, please.
yeah, so you all are belong to some universities?
No, no, no. Yeah, I have sent you a detailed like participation
Okay.
comparison.
Yeah,
So
yeah,
it includes all faculty
yeah.
members from different institutions across India.
Okay,
And
nice,
there are
nice.
students also,
Nice.
PG and UG,
Yeah.
PG and PhD scholars
Okay.
also. So those who could register on Atal portal of AICT, they have participated in the program. There are
Yeah.
200 participants who registered for the program, and approximately 146 are attending it regularly. The
Yeah.
meeting is maximum, the Zoom meeting link that we are having is maximum for 100 participants. So it's being shown here. Otherwise,
It's a
there are there.
huge number. I can see lots of
Yeah.
participants are here. That's interesting.
Those participants who are typing their code, instead of typing code, they should ask some questions or they should participate in discussion rather than just trying to make their attendance. Attendance is being recorded automatically by Zoom meetings. So there is no need to type any participant code.
Yeah. Yeah. So I would be happy to answer if anyone, Dr. Manoj, if you have any question, you can ask. So yeah.
My questions, like I was listening to your presentation while doing the sleuth modeling. I recently tried this sleuth modeling component on
Okay,
the
that's
study
great.
area that I'm deeply involved in. I was trying it for Delhi. But there are
Wow,
some
nice.
issues related to it. So because there are some physical boundaries, and those boundaries, while considering those boundaries, the direction of the growth, physical growth is basically hampering. And those physical barriers have been like whatever this sleuth modeling is considering, those are being like overlooked by the different governing bodies and, yeah, administrative bodies, I should say, in and around Delhi. And those directions are totally unmatchable to like the model that I was trying for. I'll improve upon that model. So I'll try it again, because like I
Okay.
told you, I'm new to the computer science. So I'm trying my
Okay.
hand.
I would like to add that the model is developed by a geographer, not a computer
Yeah,
engineer. So yeah.
it's more or less like it's a multidisciplinary field. If you'll see the participant
Yeah,
list
yeah,
that I have
yeah.
sent you, there are more than
Yeah.
like 40 participants who are from computer science background. And
Oh,
from
that's
geography
great.
background, there are more than 29 or 30 participants are there. So
Hmm.
those numbers are, there's a cross, like multidisciplinary number of type of people who are available in the participants list. Don't know why they are not participating in it. Otherwise, the image processing component, entire image processing that you computer science people are involved into, this is basically done in these softwares in the, let's say, black box thing, kind of thing for all of us who are
Yeah.
geographers or
Yeah.
let's say planners or architects or civil engineers. So that remain as a black box to us. But we have
Yeah.
started trying to like learning about it, like the different selection threshold while doing the neighborhood analysis or say k means type. So we are learning from this. Let's hope
Yeah.
we'll be soon able to compute. Oh, more on that, I would like to tell you guys that Ankita is involved in making IPCC report, which we keep on framing policies based on that and keep on regularly referring to. Like last report that we keep on referring to is 2007 IPCC report. Ankita will be part of the, Ankita is part of, not will be, is part of the new IPCC report. So she'll be contributing and you'll read a lot of things from Ankita in that report.
Thanks. Yeah.
One of my scholar was there and she she was not part of the participants, but she asked me to join this session specifically for the purpose of your topics, the title that you, but she's not here now. Harshita, are you there, beta? No, she's not there. So thank you very much, Dr. Ankita, and it's good to see
So,
you back in,
yes.
let's say, after 4 years.
Yeah.
So
Yeah, thank you
we
so
would love
much,
to hear
Dr.
in future
Manoj,
sessions
for
also.
giving me the opportunity. And if your student is interested and willing to ask some questions, you may contact anytime.
Yeah, she'll be contacting you.
Yeah, yeah.
She is a geographer,
Yeah.
so she'll
Okay, that's
contact
great.
back to you. So thank you very much again, and we may end the
Thank
session
you.
now.
It's my pleasure. Yeah, to be in touch. Yeah, it's my pleasure. Yeah.
Thank you. Thank you. Thank you very much.
Thank you. Bye-bye.
Bye. To all the participants, it's again requested that you should remain part in the discussions rather than like my last report also. I conducted one AICT Atal program where I submitted a report where I would directly written it that the participant doesn't fall in discussion. So there is no use of these online sessions because government is investing money in all these speakers and trying to provide opportunities to let's say learners, those who are willing to learn, an opportunity to learn from different parts of India and abroad by providing them honorarium, by providing them any amount of support that they are trying to go with. So I request you again to kindly participate in discussions. So thank you very much. Tomorrow we'll be having Professor Mahesh Kumar Jat. He'll be joining the session right at 10:15. So all of you are requested to kindly join session well in time. He'll be speaking on applications of remote sensing and GIS and hydrology. And then his second session is also there with Professor Mahesh Kumar Jat only, applications of remote sensing and GIS in urban studies. So he'll be talking on both the issues. So all of you are requested to kindly join well in time so that the session can be started right at 10:15. Thank you very much. And thank you for being there on day 3. So let's conclude day 3 and I invite you for day 4 now. Thank you.